guys, so we're going to move on to a new exercise. We've got problems in 3 dimensions. So rather than just looking at shapes and areas, we're going to look at triangles that are in like 3D objects. But we know how to solve problems in 2D, in 2 dimensions. So what we do is we end up just picking out triangles from 3 dimensions and then working with them in 2 dimensions. So I'll show you what I mean by that. So we'll look at this example here. We've got this cuboid, so A, B, C. It's got all these different points. It's a 3D object. Now we want to find the distance dB. So if you look at this, if it works, the length dB, you can see the point here D and the point here B. So we want to find that length. Alright, well, the way we find it is the exact same way we do it in 2 dimensions. What we do is we just pick out a triangle from this object. So we go, we've got D here. What else do we have? Why don't we do this one as well, because we've got information about BC. We've also got information about DC, because we know it's got to be this length as well. So we've just picked out this triangle here, although it's not a very good picture. Sorry, not very, yeah, you get the idea. So D, and we've got B, and then we've got C as our other point. Now C is going to be the right angle because, I mean, you can't really see it in my picture, but the corners are right angles. So the corner of a square or a rectangle is a right angle. So C will be a right angle there. Cool, right angle triangle. And we know that the length BC is 8 centimeters, and we know the length DC is 10 centimeters. So we've got 2 sides and we want to find a 3rd side. So we've picked out our triangle. Ooh. Great, and then now we want to find this length here. Okay, now we can use our Pythagoras theorem here because we've got 2 sides and we want to find a 3rd side. So 2 sides and want to find 3rd. Alright, so now we want to find the hypotenuse. Oops, this won't work. So remember that our Pythagoras theorem is c squared is equal to a squared plus b squared, where c is our hypotenuse length. I've just labelled it with x, you can label it with c if you want. So x squared, which is our hypotenuse squared, is equal to 10 squared plus 8 squared. Chuck that into your cas, and you will end up getting, give me a second while I calculate it, you'll end up getting 12.81 centimeters. Cool. So that's our part A done. So it's basically exactly the same as things we've done. We're just pulling out a 2D shape from a 3D figure. I think the hardest thing, and the thing that you guys probably find the most challenging, is picking out like which to use, Pythagoras, our sine rule, our cosine rule, or our trig ratios. So if you're struggling with that, go make a list of going, hey, I've got 2 sides and I want to find a third side. Then you use Pythag. And I think we've done this for all of our little measures. So with the sine rule, we had that we use the sine rule when we have 1 side and 2 angles. Or 2 sides and a non-included angle. With the cosine rule, it was 3 sides or 2 sides and an included angle. So go back through and make a little list so you can have a little like decision tree for when you get a problem. might make it a little bit easier. Anyway, we'll move on to part B. So we want to find the distance of HB. So I'm gonna, oops. So we want to find the distance of H to B. Now we just found the length of DB. We also know the length of DH. So I've picked that triangle out. So HDB. So I'll draw my H here, my D, and my B. If you look back at the triangle, that HD has a height of 7 centimeters. Now I've just calculated DB as having a 12.81 length. And again, we want to calculate, well, we know this one's going to be a right angle. We want to calculate this side here. Great, and again, so we've just used the extra information we got from last time, but it's not anything new. Well, we've picked a triangle from the 3D figure. Then we're going to use Pythag again, because we've got two sides and we want to find a third side. So we're going to use Pythag, and we'll get that x squared is equal to 7 squared plus 12.81 squared. So you end up getting 14.59 centimeters. So you're slowly getting more and more information about this object up here. Alright, so we've got two distances now. Now we want to find the magnitude of angle HBD. So we've done A, we've done B, now we want to find the magnitude. Now remember, magnitude is just another word for the size of angle HBD. Well, we've already got the triangle HBD drawn up just there. We want to find this angle here. Now we don't actually need the information from B to calculate this, but we can always use it. So we've actually got all three side lengths. Okay, so since it's a right angle triangle, so right angled, we can use our sine, cos, tan. So with non-right angles, we use our sine rule, which is different to our sine ratio, or our cosine rule, which is different to our cos ratio. I know it's a bit confusing, don't ask me why, they use the same words. Anyway, so we've got a right angle triangle here. Let's use a trig ratio. Now we've got all three sides, so we can use whichever ratio we want. So we're going to pick a ratio. I'm going to pick tan for no reason. So tan theta is equal to opposite over adjacent. So 7 over 12.81. And then you solve that in your calculator. And remember, since it's an angle, you've got to put that dash. 0 is less than x, which is less than 180 degrees. And you end up getting that theta is equal to 29 degrees. Great. So again, this is nothing new, it's just combining a whole bunch of different stuff. So we've found the magnitude of HBD. Alright, now we want to find the distance of HA. So I'm going to rub this out now. Distance of HA, so we know they're going to be in our triangle, and we'll pick D as well. Cool. So we've got, I'm going to draw this, H, and then we go down, and then below H is D. We've got A. We want to find this length here. Okay, well we know H and D is going to be 7 because that's on our diagram. We've also got the D and A is going to be 8 centimeters. So they want to find the magnitude. It's a magnitude again, I'm pretty sure. The distance of HA. So again, nothing new. It's just they want us to find this. We've got a right angle triangle. So I've drawn our triangle. Step 1. Now we've got two sides and we want to find a third side. It's a right angle triangle. So we're going to use Pythagoras theorem. So you get x squared is equal to 8 squared plus 7 squared. Because remember, x is still our hypotenuse here. And we end up getting x is equal to, let me calculate this, 10.63 centimeters. Okay. So we nearly finished the question. It's basically just doing the same thing over and over again. So we've found the distance of HA. Now, final question. It's probably going to be a little bit harder. We want to find the magnitude of angle. So remember the size of angle, H, B, A. Okay, so this triangle's probably not going to be a right angle triangle. So H, B, A. Alright. H, B, A. Alright, so what do we know about HBA? I think we've calculated something already. So we know that the length of HB is 14.59 centimeters. Okay. And we know that HA, so that's from, this is from part C. And then we also know that HA is going to be 10.63. That's from D. So that's from part D. And what do we know about AB? I feel like we've learned something about AB as well. Oh, we just know that AB is 10 centimeters. Cool. And this one's 10 centimeters. Alright, so we've drawn our triangle. Now it's a non-right angle triangle. So that probably means we're going to have to use our sine or our cosine rule. Now we've been given 3 sides. So if you look back at your notes, that means we've got to use the cosine rule. So we'll be given 3 sides. Okay. And we want to find angle HBA. So we want to find this angle here. So we've got that. If I can find my cosine rule. We've got cos B is equal to a squared plus c squared minus b squared on 2ac. So that's our rule. It would help if I'd labelled this diagram. Okay, so we've got our big B here, we'll do our little b over here. Our big A, we'll do our little a over here. Now I've got h here, so if you want you can use h. I'm actually just going to, yeah, actually we'll just use h. Doesn't make a difference. Instead of c, we'll just use h, so little h. So what I'll do is I'll go into this formula here, get little c, and put h, get rid of little c here, and put h. Alright, now we sub the values in. So we don't know what cos b is, so we don't know what b is. We know a is 14.59 squared. We know h is 10 squared. We know b is 10.63 over 2 times a, which is 14.59, times h, which is 10. Now if you chuck that into your calculator, you should get, so remember you're trying to find an angle, so you'll need to do that little bit at the end of the solve, but you should get that b is equal to 46.75 degrees. Alright, that was a bit of a mission, the last one, but the first few are all pretty okay. It's all just applying your Pythagoras rule or your trig ratios for right angle triangles, or your sine and cosine rule for non-right angle triangles. Make sure you draw pictures of the triangles that you, with the information you're trying to solve. So we know it's a 3D object, but just take the 2D stuff from outside of the object, or inside the object, and then solve the problems from there.